Can everybody hear me? Hey, welcome to Austin Deep Learning. Hopefully you're in the right spots. If you're not, you may be looking for some other buzzword-worthy meetup, say blockchain or something. I don't know where they meet. I don't know if they still exist. Anyway, hopefully you're in the right spot. In just a moment, we will turn it over to Max from Kung Fu AI, one of our sponsors, and he'll say a quick blurb, and then we'll get going. Good. Awesome.
Hi, so I'm a machine learning engineer at Kung Fu AI. So we're a machine learning consultancy. We're located here on the 16th floor at Capital Factory. So we do machine learning as a service, and we have lots of clients that cool clients up here that you can see. So businesses will come to us with problems that they think they can solve with machine learning, and then we come and try to fix them. So we are hiring, and if you think that you'd be a good fit, or if you're interested, please come. And we're also really happy to be able to sponsor this event and sponsor Austin Deep Learning. I've been coming to the meetup for a lot, and it's a really great, high-quality meetup, and that's because of y'all who come to make up the meetup. So thank you for that, and come reach out to me if Kung Fu sounds like a good fit for you.
Awesome. Thanks, Max. So tonight, I'm very excited for something we're going to try. It's a little bit new, and I'll get to that in just a moment. Before I do, just a quick intro on myself. My name is John Ramey. I'm one of the founders of the Meetup. The Meetup has now been going for 3 years strong. It's continued to, we started it out to have 5 to 10 hardcore members, and it blew up into, we nearly have 2,200 members. We have an amazing couple sponsors, namely Kung Fu, who you just heard from, as well as Capital Factory for hosting. So thanks, guys. One thing to note is that we need talks for next month, September and October. I'm looking at giving a talk on it came up in one of the journal groups recently. If you're not familiar with the journal group, it's one of our advanced groups. Our only advanced group, but there's a lot of high quality discussion. During one of those conversations, it was around Transformer XL. Attention came up, and there was a lot of, I think, a lot of hand wavy it wasn't very clear what attention meant for some folks, and so I'm looking at giving an attention talk fairly soon. But if somebody else would be willing to give that talk, I'd prefer you do it rather than myself, but I'll be happy to do it. Another talk that we would really like to have in the near future is a history of artificial intelligence, going back all the way to R.A. Fisher and Minsky and all of those early perceptron guys, all the way to the modern era. So if you talk about the AI winter that we've experienced a couple times, that would be interesting to get everybody up to speed. The impetus for this idea was a conversation I had with Jim about a very dry joke I made about perceptrons a while back during a talk. So I'd like to have somebody fill in the gaps there, like why were we laughing and why was Jim so mad at me? Just kidding. Thanks for being a good sport. So we need a couple talks, but if you're building something that you're proud to display, or you just want to give a tutorial talk over something that's intermediate in difficulty, that would be fantastic. I'm gonna stop talking in just a moment, but let me kind of tell you what we're going to do that's slightly new tonight. So I'm very excited to have. So in Slack, we actually compiled a set of questions that I will basically read to the panel, and we're going to invite audience participation during the panel discussion. But the idea is that we would like to hear, from 4 different people we have from a variety of backgrounds. I'd like to hear their views on these questions around ethics and AI. 2 requests. One is that in order to expedite Jeffrey's talk so we don't get bogged down too much, let's save questions for the panel discussion. And so I will chime in. If anybody's trying to interrupt, I'm basically going to say thanks but no thanks. Please ask the question during the panel discussion to get this going. So that's ground rule number 1. But 2, when we do get to the panel discussion, we will invite audience participation, right? So if there's a follow-up question you would like to ask somebody, or if you would like to ask your own question, feel free to do that. This is meant to be pretty informal and open to everyone, okay? And that's kind of like a general theme for tonight. Without further ado, I'm going to turn it over to Jeffrey.
Thanks so much. Can you guys hear me without the mic, or people in the back? Maybe the mic is good. Yeah, we'll keep it. Thanks so much, John, for the introduction. Really excited today to give a talk about ethical artificial intelligence. It's something that I am very interested in. I wrote my senior thesis in college on it, and I think there's a lot to unpack. It's starting to become a bigger discussion in the broader machine learning, deep learning community, so I think it should be a great discussion tonight, and I think the panel afterwards is a great opportunity to really have a diverse viewpoint on some of the things that I bring up. So, little background about me before kick off the actual content. So I'm a machine learning engineer at New Knowledge. Been doing that for almost a year now, and like I mentioned before, I worked during college on a senior thesis titled Accuracy and Fairness, an analysis of risk assessment algorithms in the criminal justice system, with professors Brian Kernighan and Arvind Narayanan at Princeton University, who are two phenomenal mentors and really helped me flesh out kind of the sophistication of those arguments there. So let's, without further ado, get started with the content. I want to leave as much time for that interesting panel as possible. So the kind of three big focus areas tonight will be first, fairness and bias, which is kind of my favorite subtopic, the one I worked on during undergrad. But the second topic on this list, interpretability and explainability, has increasingly become something that I think a lot of the machine learning community is interested in trying to develop models and approaches to solving. And then the third one, privacy, something that has been talked about a lot in the popular media in terms of the big tech companies and antitrust legislation that Congress is now potentially pursuing. So I think there's a lot of meat there to unpack as well. Three other little interesting, I think, side kind of topics to ethical AI that I don't think we'll have time to really get into today, because I want to make sure we touch on everything with, due time and unpack kind of the main ideas. But I think that my slides were shared with the meetup group, so there are some helpful images, links to blog posts, a couple, paragraphs of notes that I compiled at the bottom of the slides if you want to check out three of these kind of subtopics that I think are getting a little more press and might, in the next 6 months, year, become more interesting topics. So let's get started with fairness and bias. So maybe some of you have seen this image before. It is from a pretty famous ProPublica article in May 2016. ProPublica wrote an investigative piece about the COMPAS risk assessment algorithm, which is a kind of black box machine learning algorithm that was used to make parole decisions for defendants in the criminal justice system, used throughout a number of states in the country. And ProPublica made a pretty strong argument that the algorithm demonstrated racial bias. Also gender bias, but kind of their strongest claim was about the disparities between risk classification amongst different racial groups. And this image kind of encapsulates the argument they were making. A black female gets a high risk score, a white male gets a low risk score. What you don't see in this image is that the white male had 3 violent crimes in his prior criminal history, while the black female only had juvenile misdemeanors. Received a risk score that was almost 3 times as high, according to this COMPAS algorithm. And as you see, what actually ended up happening in the future, the white male went on to commit another pretty serious offense. The black female didn't commit any offense. But likely, if this risk score was part of the parole board's decision, maybe the black female was denied parole while the white male was let off again. Another big example of fairness bias in the news, Amazon's software Rekognition, right? The facial recognition software that is used by a couple policing departments, I'm pretty sure Oregon and Florida, although it originally was deployed in Washington state. There was also some press last summer that Amazon was in conversation with ICE, actually, about having the Customs and Enforcement Agency use this algorithm as part of their policing strategy. And what has been demonstrated by a number of studies is that recognition displays gender and racial biases as well, because there are fewer images of certain demographic groups that it has been trained on, and therefore it is less accurate when trying to classify or match those faces to a face in their database. So, do concern about using this in, especially by groups where it would be applied heavily on populations it's less accurate for. So these two examples kind of kicked off a really nascent, exciting literature technically about fairness. In the last few years, especially in computer science, but also amongst a lot of interdisciplinary academic coalitions, we've seen a pretty sophisticated discussion of what is fairness, how do we define it, how do we measure it, a little bit less, how do we mitigate it, but starting to see some more there. And so a talk actually by my second reader on my thesis, Professor Arvin Narayanan, at the Fairness, Accountability, and Transparency Conference, which is a new conference gaining a little bit of traction. And the main point of this talk is that there were 21 different definitions of fairness. And I think a little quip at the end was ... and there are more. So there's no shortage of discussion on how do we actually define what makes an algorithm fair. What should we, what should we interpret? What should we analyze to try to decide if we think its classifications or its regressions are unbiased? So I think one thing that's important, and I know this is a slightly more technical meetup to get into, is kind of a methodic take, a precise take on what definitions we need to establish to talk about fairness rigorously in machine learning. So if we take kind of the most simple example of a machine learning problem, we're just doing binary classification. We're trying to put examples, instances into group A or group B. Predict D, and say D can have two outcomes. You're either hired or you're not hired. And the input here is X. That is our instance, our person, our sample, example. And let's say X has 3 different features or attributes. Here, race, which is represented by A in the diagram, socioeconomic status, represented by C, and education represented by M. And I'll define one other variable which isn't shown on the image, but Y represents what actually happened. So if the algorithm is trying to predict D, trying to guess if somebody will be hired or not, in our set of training data, Y is the actual outcome that was associated with some of those examples X. So these 5 kind of terms that I put to the left of the image are, I think, the crux of discussing fairness academically. So the first is there's a characterization of an outcome as either favorable or unfavorable. In this example, D is the outcome variable, and that is favorable if you are hired and unfavorable if you are not. One of the classification outcomes is more preferable than the other one. The second thing that you kind of need to define is what attributes of the example, here example meaning X, what attributes of the instance are protected and which are left unprotected. Protected here basically means what should we consider something that we want to, protect against. We want to preserve equal treatment kind of for that attribute. So here race would be the protected attribute, but maybe education or socioeconomic status, those wouldn't be protected. Next, privileged versus unprivileged group. That one might be a little bit confusing with the previous protected, unprotected attribute. But basically it means out of the set of examples you've seen, which groups have historically received more of the favorable outcomes. So for example, if our protected attribute is race, maybe we have 2 different levels of that attribute, white and black, and historically, people with the white attribute have received more favorable outcomes. Therefore, if we are trying to remediate kind of fairness or enforce some fairness constraint, we want it to privilege the group that has historically been disadvantaged. So the black defendants, the instances in the training set where the attribute A is black. Finally, let's just step back for a second and highlight that bias here is not the classic bias in machine learning. So if you've read a kind of an introductory textbook, you've probably come across the bias versus variance trade-off, where bias is kind of a predisposition to a certain model or function, and variance is the kind of the space of different functions you can learn. This bias is not that bias from that trade-off, right? This bias is specifically an indication that a algorithm is disproportionately affecting a certain group. Okay, so this is the bias that you think about maybe in like a sociology discussion and more of an interdisciplinary conversation. And then finally, kind of something that's important throughout machine learning is defining a metric, right? We need a mathematical way to assess whether something is meeting our criterion. So a big part of the literature I mentioned on fairness is defining how do we actually measure these ideas, how do we measure fairness mathematically. So that kind of transitions into the next set of content on fairness. In that talk at the conference in 2018, there were a ton of different definitions of fairness. A lot of them are pretty attractive. They seem reasonable, they seem interesting, and I think one thing the community has taken out of this literature is that there's a lot of legitimate arguments to be made about how we define fairness rigorously. So one potentially attractive definition is simply removing that protected attribute. What if we deleted race from the data set and then learned an algorithm on that? That seems attractive, right? You cannot learn from this protected attribute. The problem there is the protected attribute could be redundantly encoded, meaning kind of appear indirectly in a number of the other attributes. For example, here, what the graph on the right implies is that race might indirectly impact somebody's education level. And therefore, education as a variable or as an attribute would actually be correlated to some degree with race, and therefore, even if you just delete that column with the protected attribute, you're not really getting rid of the problem. So that kind of brings us to the second definition. We need something with a little bit more meat. If the protected attribute is still included in our set of variables, how do we enforce fairness? So one definition is, what if we look at groups as a whole? And so this is also referred to as demographic or statistical parity. If you ended up reading any of the papers in the literature or started to dig into it a little bit more. But basically what it means is that the probability of predicting one level of the outcome variable, so here the probability of predicting hiring positive, so predicting that the person was hired, is the same for both the set of samples where the protected attribute is black and the set of samples where the protected attribute is white. So what it means is basically we have the two different demographic groups. One is protected, but if we look at their classification averages overall, it's the same for both groups. So this seems a lot more palatable. Now we have something that kind of enforces each different group as a whole is being treated evenly, fairly. But a problem here is that it really kind of ignores the individual amongst the group, right? The incentive here is to make the group averages the same, but it might mean that an individual with a ton of criminal offenses or other attributes that might point them or sorry, using, I guess, kind of the hiring example is more appropriate. An individual with just a high school degree and maybe no previous job experience could be put in the box predicted hiring to make sure that the two group averages are the same, but it really doesn't, it's really not a good prediction for that specific individual. So from a machine learning perspective, it kind of encourages poor classification, and some of the approaches that use this constraint actually lose a lot of accuracy, and kind of, what the automatic algorithm was bringing to the table is lost, right? You could just have somebody kind of use their intuition, a domain expert, talk through it that way. So that kind of brings us to this third set of fairness definitions. Let's look at constraints on how we treat individuals. So one proposed definition, and these can kind of get a little bit in the weeds, so I tried to put the mathematical definitions up there for people who can interpret them, but I'll try to talk through them in words at a more high level. So the first definition is asserting that the true positive rate and the false positive rate are the same for both groups. So basically what that means is that the error statistics, how often the algorithm is, thinks that somebody will get hired and they actually did get hired, or thinks that somebody won't get hired and they actually didn't get hired, are the same, conditioned on people of one protected attribute versus the other. Another argument for individual fairness is looking at conditioning kind of in the other direction. So calibration, if you look at the probabilistic definition, is really defining a similar kind of constraint in terms of the error statistics, but it's conditioned on the score that was predicted by the algorithm, and instead of conditioned on the actual outcome. So what this tries to equate are statistics called the positive predictive value and the negative predictive value. I don't want to get too much into this because, again, it's kind of statistically it's different, but it can be kind of confusing if you don't have time to work through the examples and look at kind of a confusion matrix of true positives, false positives. But basically, these definitions, different definitions of individual fairness, can actually lead to slightly different constraints on how we treat examples or people. And then the last definition of individual fairness, which I think is pretty interesting, attractive to a lot of kind of groups, organizations, is this idea of distance metric fairness. So what this means is if we have two individuals from the training set, say X and Y, and those individuals can have either value of the protected attribute. So they could be black or white in this example. The formula, the expression on the right side, the D1, is the distance between those two individuals. So if we kind of look in the high dimensional space of all their features, what is the distance between these two examples? And what distance metric fairness wants to do is it wants the predicted outcomes on these two individuals, the distance between those predicted outcomes to be less than the distance between their features. So basically what that means is any two individuals who are close in terms of what their race, socioeconomic status, education levels look like, need to be predicted similarly by the algorithm. And you could even see that being an attractive definition if we played with some of the variables. What if we took out race and we said everybody who had a similar education level needed to have a similar hiring decision independent of this protected attribute. So that's starting to get to something where we can actually apply a constraint on the algorithm and still optimize it and try to produce the highest accuracy, but it has to treat everyone who looks similar the same, ultimately. So another slide with a kind of mathematical fullness to it, put it ironically. But so a really interesting paper that has that was written in 2016 after some of these initial definitions is by a scholar named Alexandra Choldachova at Carnegie Mellon. And specifically what she was highlighting is that if an algorithm achieves that second definition of individual fairness, calibration, so don't worry about the technical specifics of calibration, but basically if we achieve one definition of fairness, individual fairness, but the base rate is different for the two different demographic groups. In here, the base rate, or sorry, in the graph example, the base rate would be what percentage of black individuals are hired, or what is the probability that a black individual gets hired on average, and what is the probability that a white individual on average gets hired. So kind of the base average for that demographic group. So if those averages are different, then we actually can't achieve the other definition of fairness where the error rates are the same. And so basically what she is highlighting is in almost every practical application, think about the criminal justice system, where the base rate is the recidivism rate or the arrest rate, those base rates are likely to be different for the protected group and the unprotected group because of historical biases, because of the way that individuals interact with the world, and that means we actually can't achieve multiple definitions of fairness. And why that's important is because it means we have to choose specific definitions of fairness, right? We can't just say, this is fair across the board, it's palatable, we can use it in practice. We have to be really specific about what does fairness look like in this application, what is most appropriate in this application, and then that is what we can enforce the algorithm to adhere to. And if you want kind of more information on this, I would definitely recommend checking out that paper. It's actually like only 5 or 6 pages. It's kind of a really elegant discussion of this theorem and the implications from it. There's some nice visualizations too. So again, the big kind of the crux of her argument is that there is going to be a trade-off between these two major definitions of fairness, except in the really naive case where the base rate is the same. The average is the same for each of the groups, which pretty much happens in none of the applications that we actually care about fairness for. So the last thing I wanted to kind of highlight about fairness and kind of prepend or add append to the end of each section of my talk, just a few really good resources, I think, on the specific topic. So again, these are linked, I think, on the meetup page. There's a really nice online book by 3 of the leading scholars. IBM actually put out a full API that has where you can apply these definitions of fairness to your algorithm, kind of as a black box, if you just define some of those initial things. And then also, they have some of the cutting edge research in fairness, where they actually try mitigation strategies, different approaches to changing the data such that you achieve a better result by these fairness criteria. Okay, so I think I want to save as much time as possible for the panel, so I'm just going to walk through this next section on interpretability a little bit more quickly, and then we can save privacy for kind of the overall discussion amongst the room. And again, the slides will be up there, so feel free to check out, any of the resources that I don't have time to cover, but I think interpretability is a really exciting area right now. It's also fun to look at in terms of slides. There's nice visualizations. You can see what's happening. And so I'm going to highlight kind of 4 subsets or sub-ideas in interpretability quickly. And so the first one is feature importance. That's something that if you spent a little time in machine learning, you might have some awareness of. And it's basically trying to assess which features were most important for the algorithm on a specific prediction. And so there's been a couple of interesting approaches to this. One is called LIME. Another recent one is called SHAP. LIME stands for Local Interpretable Model Agnostic Explanations. And so the 2 kind of key pieces there are first that it's local, which means it's just focusing on samples near the instance you're predicting. So it's not trying to claim an interpretation for the whole space of the model, but just locally around the example you're critiquing. The other key part of its name, model agnostic, means that it's data dependent and not model dependent. So it interprets the model coming in as a black box, and it's just going to fit a really simple linear model around that local area and then interpret which features were most important. The argument there is a local model is kind of legitimate, a linear model is legitimate locally. That's kind of a smoothness assumption on the function. And then you don't have to worry about the model really affecting the interpretation of your prediction. So this is what these kind of two graphics depict in this example. The top example is the LIME algorithm, the LIME interpretation method, and it picks out a couple binary features here, the features being words in the text that are more associated with category atheism or category Christian, and then based on which of the features are present in this email text example, you can directly see which words led to the prediction of the class of that text. On the bottom, it's another, the SHAP interpretation method I mentioned. Don't think we'll have time to get into the nitty-gritty there, but it's another approach to looking at individual features in the model and seeing how much they move the prediction away from its overall average. And it produces these kind of nice visualizations where you can see how much one feature is pushing the average up or pushing it down. Another kind of cool, some cool recent work on interpretation is coming out of Google around object recognition and detection, or digital image processing. And you might have seen or heard discussion about saliency maps or class activation maps. And what those are generally are taking the activations from one layer of the neural network and then performing some dimensionality reduction on them so you can visualize them nicely in 2 dimensions, and usually taking the average of the activations in some bounded region. So that's how they divide up this grid here. But what you explicitly actually see on the screen is, so on the left side, let's see, stage left? Yeah, stage left. Stage left, there's the images for the IBEX class of the ImageNet model, which is some mountain goat. And what's kind of interesting is half of the activations are around horns or kind of physical features of the animal, but the other half of activations is around environmental features, right? Like the hilly landscape, the mountains. So you see kind of the 2 different things that this model is picking up on to classify. What I want to kind of highlight with the other image is how helpful interpretability techniques can be for debugging models. So you see the grid in the bottom right-hand corner that's bounded by a yellow box. Looks kind of like the opening mouth of a great white shark, but it's actually a baseball according to the training data, right? So this is showing how the model, picking up on kind of that pattern of red seams or mouth and teeth, misclassifies a baseball as a great white shark. And so seeing this visually is a lot more helpful than seeing, some array or vector of floating point numbers and trying to figure out where is the model going wrong. Similarly, we kind of see this attention or focus diagram in natural language processing. So what John was mentioning at the outset of the talk, attention's a really popular new idea in text processing, where we actually model the relationship between each word in the input and whatever word we're trying to predict, instead of maybe just combining a lot of words in some hidden state. That's kind of the recurrent model. And what you can see here is a really difficult problem for text. This example is co-reference resolution. So when you have some pronoun that might be the referent of either of two nouns, and you're translating it to a different language where maybe the gender of the pronoun matters, right? So if this was going to French, you have to know what gender are we translating it to. And that'll be different if it's associated with animal or street, potentially. So you need to figure out, does it refer to the animal, right? The animal didn't cross the street because it was too tired, or does it refer to the street? The example on the right, the animal didn't cross the street because it was too wide. So what this attention mechanism does is it allows kind of the relationships between individual words to be more directly modeled, allows a kind of a longer memory or a longer interpretation, which had been a problem in natural language processing and still kind of is. And so the last interpretability method I wanted to highlight quickly is that of causal graphs. So if anybody's come across the work of Judea Pearl at UCLA or some of the groups associated with him, it's a popular book called The Book of Why that maybe some people have read. It's a great read, by the way. But what causal graphs try to do is specify causal links between variables that a domain expert specifies and allow those to really reduce the joint distribution, so the distribution over all of these variables, to a sequence of conditional distributions. So specifically, if we had a bunch of data and we didn't know what this graph looked like, we would be trying to learn the probability of A, C, M, and D, all of those variables at the same time. But what the causal graph allows us to do is see that, okay, the probability of M just depends on A, on A and C. The probability of D just depends on A, C, and M. And you can kind of break down the probabilities that way to make more specific interpretations about your model. This also helps you answer counterfactual questions. What that means is if you have a causal graph and you say, okay, but what if the value for A was flipped? What if in this example it was the race of the person was white instead of black? You can directly see how your ultimate classification probability or your ultimate regression variable would change because you have a model of how the variables causally affect each other. So that's really attractive to kind of interpreting those models. Yeah, so with that, I think we should, transition into the panel discussion. Hopefully we have a lot of interesting thoughts. And again, there's more content in the slides, so feel free to check it out, some more resources. I tried to plug those in at the end. And thank you so much for your time.
Thank you so much, and Jeffrey, for the wonderful talk. As you can tell, we have some pretty high quality talks here at this meetup. Some are pretty technical, some are not as technical. Like I said before, we're going to start with something that we've never done before. So at this point, I'm going to invite the panel up to the stage by Jim, Alex, and Jeffrey. Jeffrey, you cool if I
Yeah, you do whatever you want. You just want me to show it?
Yeah, go ahead. I don't want to. I'm going to move this thing.
Oh, okay. Yeah. Save forward.
Let's get a second. I got a couple extra mics, so pass these on. Yeah. Here's one. There you go. Thank you so much. So let's get started. So just as a reminder, so before we set up this panel, we compiled a set of questions from a variety of folks that we're going to ask tonight. So there's going to be an obvious thing here, which is that our panel was a bit biased, and that wasn't by design. That's my fault and my fault alone. So if you would like to blame somebody, please blame me. But we would like to invite anyone who has something they would like to say to answer a question. Please do. We do want this to be an inclusive conversation. So with that said, let's get started. I'm going to switch to the other side of the stage. All right, so the first topic that we're going to go through is fairness and bias, which Jeffrey just kind of went through with us. So there are very famous examples where groups are underrepresented in data sets. Famous examples of this include African Americans in Google Photos image search, Southeast Asians with Nikon and Sony cameras, recidivism, which you discussed previously with the criminal justice system, other ones just in general, healthcare, criminal justice in other ways, and lending of all things. So with those in mind, how should we facilitate underrepresented groups participating in workshopping?
John, we should introduce ourselves first.
Oh, yeah. Thank you so much. Let's do that.
So we have already know the speaker, so let's start with Jim.
Yeah, good idea.
I'm Jim Talley. What do you want to know? What should we do?
Name, what do you do?
I run a startup right now doing speech technology stuff. I've had a long history in machine learning, dating back to prehistoric days, and I don't know what else.
Tell a little bit of your experience with Mikael.
I was a tenured graduate student at UT because all of the machine learning people came in, and I was in their very first class, and they all got tenure before I left. So, anyway.
My name is Alex Mabley. I'm a data scientist at New Knowledge with Jeffrey. And I've only been there about 6 weeks, and prior to starting that, my background is in the academic world, most recently cognitive neuroscience postdoc at UT.
Hey guys, my name is Abai. So a lot of you already know me. I'm one of the organizers here at Austin Deep Learning. I do machine learning and computer vision for Apple, and most of my free time goes. I'm heavily involved in technology in Austin. So I like to give talk. I do some consulting, organizing. So if you're interested in getting involved in Austin's tech community, or you're new to Austin, I would encourage you to talk to me at the end of the talk.
Cool. Thank you so much, Abai, for keeping me honest, introducing everyone. Just as a reminder, my name is John Ramey. I lead the data science team at a startup here in town called Novi Labs. All right. So with that taken care of, mentioned before, a lot of famous examples where we have underrepresented groups in data sets, and that underrepresentation rears its ugly head in the form of underrepresentation or bias in our algorithms, our models. So the question for the panel is, how should we facilitate underrepresented groups participating in workshopping definitions of fairness, protected attributes, and privileged, underprivileged groups?
I would say that the solution starts in the hiring process, and the more representation you have on your team, be it kind of education background, gender, culture, race, the more quickly someone's going to raise their hand and say, hey, look, I'm not represented in this data set here, and we need to do something about that. And I think it kind of reflects on the lack of diversity in tech, that so many of these problems have come up, and no one's caught it earlier than they should have. So yeah, I think it kind of starts at that level, and then it'll maybe filter down.
So I was just going to say that. So there's that issue of the actual production. There's also the issue of what we take to be the set of protected groups and the ways, and what are the problems that we care to attack if we were aware of those problems, right? And obviously the things that have made it into law, sort of the anti-discrimination laws in the U.S. and around the world are important. As an initial starting point, I'd like to point out that these are all kind of socially defined issues, and whatever kinds of solutions we approach this with, we have to be cognizant of the fact that the world is going to change. So, for example, race was not at all a protected category in the 1930s, 1940s. Women weren't sort of protected and of interest until, say, the 1960s. LGBTQ didn't enter in consciousness until whatever, the 70s or 80s, right? Maybe later. And things will continue to evolve and change, and solutions that we look at need to be aware of that fact, that it's an externally defined issue. The data is going to tell us what the data tells us, and we need to have a means by which to compensate for that, for the statistics of the real world data.
So let me ask a follow-up question. Let's put at some point we actually have to, as practitioners, we have to actually implement this stuff. So we have some high-level ideas about, let's hire better, let's test better. But how would you actually do this in practice? So hiring, I think, is a little bit more straightforward, because that's in the public spotlight, not just in tech, but outside of tech. Let's put the hiring one aside just for the moment, because it's not just going to come down to hiring. Just given some of the examples I mentioned before, how would you actually go about ensuring that you don't have bias in your model, right? Let me say it this way. It could become a cat and mouse game, right? There's you identify a source of bias in your data set, a lack of representation, you address that one. Then you identify another lack of representation, you address that one. This could continue multiple times. How would you go about practically addressing these concerns?
So the one big problem, I think, when dealing with complicated black box models in very sensitive areas like hiring is the computational cost. You're already acquiring a lot of computational cost and training time by building these models, but now you spend time analyzing and spend computation actually making your model interpretable or trying to get the biases out. So I think at this point, being fair is kind of a privilege. There are like libraries. For example, Python has a nice library called Fair Test. So it has all the common statistical errors that people make and some unwarranted correlations in your data set. It will like point it out to you. So there are things like that. H2O AI has a nice blog and tools, for example, like maximum activation analysis that will basically propagate your data and compare it to how random data and your actual data activates the neurons in your network. So there are practical things, but at this point, I think the issue is it takes a lot of computational cost. So right now, like one of my jobs is deploying one of the machine learning applications, and the big challenge I'm facing right now is the computational cost, and I can't even imagine running overhead like also running the fairness test every time I train a model. So it's really hard. So I think the fundamental research is not there yet, where we wouldn't inquire the overhead by testing for fairness. So I think we need some more practical ways of doing fairness in our models.
I think the content of that answer is kind of also exactly why we need to separate regulation from implementation. So I think we've seen a lot of problems when private corporations kind of regulate themselves when they say this is fair or this is just by my definition. And so this is something that Cynthia Dwork, who's a professor at Harvard, has pointed out, is that the definitions of fairness, kind of the constraints that are going to be imposed, should be discussions between interdisciplinary groups that are evolve socially over time and are iterated on and updated. And those should be the constraints that individual practitioners need to abide by if they are going to make, a prediction about parole or a prediction about whether somebody should receive a loan or something like that. So I think it's critical that the constraint comes from outside or at least, yeah.
I have an opinion about that. So I think we shouldn't rush too much with regulations because what we see in all the industries, right? For example, in healthcare, when there's some kind of error, like what we have seen in social networks or companies, we've seen some kind of bias or some horrible thing happen, and we have this hindsight where we say, okay, they didn't do something correct. Okay, they were very foolish, but matter of fact, they were doing everything they could. It's just they didn't see what they could. There was no way of predicting that that's gonna go bad. And most of the cases, people mean well, but they can't really predict it. And for example, with doctors, right? Doctors give up their lives to save other people's lives. And right now, because there are regulations, and because doctors and hospitals get in a lot of trouble, doctors will prescribe unnecessary tests, not for the patient, but to protect themselves. So I think if there's the machine learning field is still very young and developing. I think if we rush with laws, we will start protecting ourselves from the laws, not actually enforcing the fairness.
I do think one thing that gets conflated a lot is that regulation has to be something that's really expensive and computational. So, for example, in a lot of the algorithms in these papers, they show that specific fairness constraints actually allow algorithm development that is the same, if not 1 point lower in accuracy. And what that means is it could just mean that the community comes together and says, the false positive rate in facial recognition has to be the same for these 5 demographic groups if you want to deploy it, in production. And that doesn't seem like a super, computationally intensive, addition to your development procedure.
Yeah, one, of course, big issue with that is actually, the legislative process, the understanding by the general public of what's involved. And one thing I was reminded that I wanted to point out is that I think we as a community of machine learning people need to make an effort to educate the general public as to what machine learning models are and how they work. Specifically avoiding, I have heard multiple times already, just kind of in general talk, that the conflation of machine learning with programming and the idea that machine learners are programming in bias, right? As opposed to not being wary enough about making sure bias isn't part of the system. So just a side point.
So let's invite a couple of people from the audience to either chime in or ask a question of the panel.
Just a comment. It seems like the dream of AI is that it'd be more fair than we are. It seems like the dream of AI, if you read any old science sci-fi book, is that it would be more fair than we are. But from what I'm hearing you guys say, it sounds like we're still stuck with ourselves. Would you agree, or do you think there's a way that machine learning can make us more fair?
I think you're correct, right? It kind of comes down to, a funny question, I don't know how to say this, but it's kind of a question of who decides what's fair, right? So if you took the most civic-minded among us and you gave them the right to decide what the standards should be, you would end up with a more fair world than you would get with, how should I say this, with the Donald Trump base driving the decision, right? And so, you have this whole issue of kind of, democracy versus, whatever, plutocracy. At what point do you, like who gets to decide who decides even, right? But that's kind of the issue. Yes, we could be better.
So let's move to the second question because it's related to what you're saying. So if you think about classic sci-fi, I had that in mind when this question came up in Slack. So I'm just going to ask the question, then I'll relate it to sci-fi in just a moment. Some researchers have argued that model interpretability is vital for society to accept the decisions made by a machine learning algorithm. Whereas other famous researchers say this nonsense. Interpretability doesn't matter. The only thing that matters is a very powerful algorithm. Famous researchers in that regard, Jan LeCun, Ian Goodfellow to some extent, and many other famous folks. Interpretability is not an issue. How important is it to open up the black box? So coming back just briefly, I'll ask the question again, briefly to the sci-fi, I've just always had this view of some robot, some decision maker. I'm thinking Futurama, if you've ever watched that show, where somebody is making a decision that I am now going to prison. I'm like, well, why? You know, it is deemed on high that you are going to prison. Why? No answer. There's just an assumption or a presumption that I am a criminal. So that's my silly relation to your hard sci-fi. But to the panel, how important is it to open up the black box, or do we even need to?
Yeah. Initially, I agreed with Jan LeCun, but there was a panel, right, with Jan LeCun and who's the professor for NLP at Stanford? Anyone knows? Remembers his name? Stanford popular NLP course. What is it? No, I don't think it's him. It's the older, bolder, very nice guy, very kind guy. But yeah, they were arguing. He was arguing pro interpretability, and he was like saying it's essential. And Jan LeCun were saying, we don't really need it. Like, if you think about it, right, the whole point of designing the machine learning algorithms is so we don't really have to do that thinking, because so we don't have to tune every single thing. So it kind of automatically learns the patterns in data and in the future patterns in behavior. So we're basically trying to encode things in automated fashion. And I think interpretability matters, but we should not be trying to dumbify the interpretation from the models, but rather rise ourselves up to it. So I think every single machine learning engineer has a responsibility to elevate their thinking, go higher in their analysis, like spend more time understanding the concept. For example, probably a lot of people here do not even understand what you said by local interpretability, right? And if you understand what local interpretability is, then it makes a little bit more sense. But the main issue is the way we could interpret it right now, dumbified, do it either linearly, in which case we're just lying, or do it locally, in which case we're just seeing very small picture. We're not seeing the whole model. So to see at least some part of the model, I think we have to elevate ourselves to a point where we understand more abstract concepts. And when we're explaining, we're not saying variable A, variable B, but rather we're understanding the whole system. So maybe understanding dynamical systems at least in some very basic sense. So so one of the most important skills, I think, is mathematics. So freshening up a little bit with mathematics, understanding some of the mathematical concepts could help make models more interpretable without dumbifying them or lying to yourself.
I'm going to have to disagree a bit with you. I think that the whole purpose of deep learning, when you've got models that are 8 billion parameters, there is no simplification of that model that humans are going to understand. I'm sorry, it just isn't. It isn't going to happen. And you're talking about machine learning scientists, right? I mean, I definitely think we should try to do explainability for the process of research in machine learning to understand, where models go wrong, what things happen. Again, that's going to be a very poor understanding of what's actually happening. It's going to be a very strong simplification. But in terms of explanation to, again, the general public, and to have that be, sort of accountability, I think it's just the wrong goal. I mean, I don't think that that's going to be reasonable. Yeah, so I'm kind of with LeCun.
Microphone.
I think we agree. It's just we need very different sets of tools to analyze them. Like we need to invent like new way of thinking about them to make them at least somewhat understandable. Not fully interpretable, but at least somewhat understandable.
Okay, I'm going to poke a little bit. So to bring this back to a very grounded scenario. So at the beginning of Jeffrey's talk, you saw a parole example where you had a black female with a risk score, I believe it was 8, and a very shady looking white dude with a score of 3. And without looking at the back of those 2 baseball cards to see their background, somebody might have said, that makes sense. Whereas I think the majority of us would say, no, that's not going to fly. So if the goal is to, if in that situation, let me ask the question again, how important is it to open up the black box in that very scenario? And how would we do it?
Okay, very, very quickly. I think it's important to mitigate. I don't know that it's necessary to explicate.
Care to elaborate? Don't dodge the question.
I hate to monopolize it. So for example, I mean, Jeffrey's coverage of this was far more thorough than I've spent any time thinking about. But just last night, I was thinking through a method of mitigating that would be, relatively simple, where you take and eliminate data. So you take let's take the recidivism case, and you come through and you eliminate all of those protective factors from the actual input data. Now, you've got the correlations that allow you to predict those things within the data still. But I would take and, just maybe brain dead, shoot it down if you want. Take and train auxiliary models beside it from the reserve data to get the eliminated items, the protected items, right? So therefore, you now have a model given all the available data that predicts whether somebody is black, brown, white, green, yellow, or whatever. And then you basically make a probability of this and then after the fact essentially do sort of a reverse Bayesian operation where you back off of the specificity of the original model, you discount it, to remove the predictability of these various attributes.
So to the panel, I'd like you to put yourself in the shoes of 2 people. One, the black lady who's been told she has a high risk, and 2, the lawyer defending her. When you see those 2 scores, what evidence would you need to see to convince you that that score is fair and just?
So I mean, I think the why question is the strongest argument for interpretability, which is that if somebody's making a decision about you, you have the right to say why and get some explanation that isn't ... because, right? That there's some content there. So I was actually listening to a podcast today with interview with Cynthia Rudin, who's an interpretability researcher from Duke University. And one example she gave with the COMPAS algorithm was actually a typographical error. So meaning that data was actually entered incorrectly in the database, right? Somebody's name was misspelled, or their, the number, there's a 0 added to their number of prior criminal convictions. And in that case, statistical probabilistic methods aren't going to de-bias that data. But if you look at an explanation that says the reason this decision was made was because you had 10 convictions, and the lawyer says, well, that's not true, that's a pretty powerful, quick remediation of a problem. So that's why I think, yeah, it's still important.
Yeah, I would agree, kind of going on from Jeffrey's point, for explainability for the general public's both trust of the model and also, or trust of the decision, and also the ability to have some recourse. So in, the classic example of like a loan denial, like why are you being denied the loan, and then what can you do to try and combat that? Like, how can you improve yourself to try and beat the system if you have no idea what it's scoring you on or how it's making that decision? Like, it's a losing battle. And if we're assuming these models are fair, and it's not just based on your race or your education history, and it is something in your kind of financial background, then that's something that you might have the ability to change, and you should have that opportunity.
So I think the place you really should be looking at is the data, and like very basic, the specific data that your model was trained on. And like the very basic statistical flaws, like skewed distribution towards specific category, right? Things like that. And should I say this? I'm gonna talk. This is going to be a little bit. This is a little bit dangerous.
You are on camera.
Okay. This is a little bit dangerous, but what I'm gonna say is when we're trying to, for example, prevent the model from giving a higher score to an African American female, right? Is I think really what we're trying to do is prevent a positive feedback loop. So the true statistics are that's the truth. Right? The statistics are that African Americans have higher rates of crime, and I'm not saying that's because they are that way. We know that there's a lot more context, and there are reasons. There are more complicated reasons for that. Yeah, and so when we're doing it, when we're giving them when the data is like that already, and this model that's already making, it's like a reinforcement learning environment, right? You try something, you actually affect the environment, and your model your data changes again, and it gets more skewed, and this is like a positive feedback loop. And I think the issues like this, we cannot predict them. There's no way of predicting it. I think there are a lot of times, really the reason why we're worried about social issues like race, right, is specific instances in our history, like slavery or Holocaust, only because of things that we're really sensitive about the racial issues. There are a lot of issues that we don't really worry about it because they're not very recent in history, and the basic truth is there is really no way of predicting problems like that. That only through trial and only when something happens we can actually see it. And I think that when we do see it, we have to we shouldn't lie to ourselves, but we need to proactively fight the positive feedback loop. So when we look at the data, and when we know that there might be some kind of positive feedback loop, we need to stop it proactively. Not change the theory of machine learning, but specifically change how we train the specific model. And yeah, I guess I will.
So let me turn this to the audience. You can either respond to what has been said on the panel, or you can ask your own question, etc.
So my question is, maybe I just don't understand it maybe, but why not just throw the data out altogether and start with fresh data for that?
Basically, you would be fabricating data at that point, right? I mean, you have big models have big data needs, and to the degree to which you start manipulating the data, you may get unintended consequences, and you have to have data. So if it is already, unfortunately, a loop, a feedback loop. Right?
Anybody else? Oh, here we go.
Is the demand mainly coming from academia or as well like large corporations and things? Because surely there'd be some incentive to stick as close to the predictions of the model as possible, or the accuracy.
I would say neither. I think it's becoming more from public perception than anything else. The demand to clear this up, and justifiably so.
I think there could also be a thing, the difference between predictive and prescriptive analytics. So if you're just being predictive, you're giving someone an advisory about something, a score that a person can then go and act on, or actually being prescriptive and actually taking the decision away from the human being. I do a lot of work with public sector bodies, and a lot of them are very, very nervous about, especially the prescriptive models, because even the whiff, as with ICE and Amazon, for example, even the whiff of this happening can affect public trust if they can't then be told exactly why something was happening, if the human is not in the loop anymore.
Okay, let's shift gears. I saw a couple of volunteers and apologies. Got a handful of other questions. So we've been talking a bit about things that are centering around race and gender, and those are very important, of course. But there's a lot of other ethical issues that we have not even discussed. A couple on my list here are privacy. That's a big one lately. Deep fakes, if you're not familiar with that concept, I'll define it in just a second. But before we get to deep fakes, let's focus on privacy. A few recent events, Facebook in mind, with data privacy. I think everyone has a sufficient background with this, so no need to introduce it. Go straight to the question. So what legislation and responsibilities should be enforced upon corporations around the way in which they interact with and exploit individual users' private and sensitive data?
Yeah, so there we go. I think, so kind of another appendix to my talk that I didn't get to, but I think a really interesting idea in this field is the idea of information fiduciary. So fiduciary is the idea of basically certain individuals that professionally have a responsibility to act in the best interest of their client. So lawyers, accountants, people like that. And fiduciaries, are legislated. There are regulations, definitions around those. And what some professors, both in the legal world, computer science world, have identified is that tech companies are no different than these fiduciary institutions, right? Lawyers, accountants, they are utilizing and profiting off of other people's private information, for monetary gain, and they're not thinking about the best interests of those people that they are exploiting. So I think the first step there would be to look at people's private information, as a right, and think about the regulations on a company in terms of they must interact with that data with the best interest of the producers of the data in mind.
So that's a good answer. I'm not going to follow it up with anything other than just a note. You call it fiduciaries. I've also heard it called data trusts. A famous researcher named Neil Lawrence. He's one of the co-hosts of one of my favorite podcasts called Talking Machines. He's actually given quite a bit of thought to something. He's labeled it data trust. It's in addition to your fiduciary. So coming back to the original question, anyone else would like to chime in on the panel?
No, I agree with what he said.
So let me ask a slightly different question. Take Facebook recently. What incentive is there for Facebook or a similar corporation to remotely give a crap about a user's privacy with respect to their data?
Yeah, I mean, basically, it's going to come down to legislative stuff. I mean, they've gotten away with, basically being robber barons for a very long time. The GDPR in the EU and similar kinds of laws are a beginning where there's some actual hefty penalties against kind of abuse. But also, classically with any misbehaving businesses, you've got to vote with your feet. I can say, personally, I've never been on Facebook or Twitter. I don't use Google for virtually anything at all. As much as Gmail is a great product, would love to use it, I just completely disagree with the fact that they read all my emails, and I'm not going to use it. You're sort of giving up a lot of the conveniences of day-to-day life, and if people started doing that en masse, there might be a little more conscientization about what you should and shouldn't do just from their own, profit motives.
I completely agree with that. I think there's a need to educate the public as to exactly what information they are giving away. Like people in this room probably understand what data can be collected on them when they click on a link or check a box or sign up for something, but the kind of mass general public have absolutely no idea like what information they're giving companies access to. And I think that's kind of, if you could educate people, they might be more willing to en masse walk away from Facebook or Gmail or whatever and not kind of give up their data for that convenience.
So I'm going to follow that up with an additional question. So it's one thing you'll hear people say is that we should respond with regulation, and that is one approach. My concern with that one in particular is that if you take Zuckerberg's famous panel, what was it, about a year ago, 2 years ago, where the people interviewing him were not very well equipped technically to discuss Facebook with him, how would they be able to regulate these matters? So an alternative here would be to combat via dollars, with money. How to do that? One approach I've heard proposed is lawsuits. Classically, corporations are very conservative when it comes to lawsuits. As soon as the lawsuits start flying, that's when they tighten their belts. That's when they start paying attention to these matters. So one approach, as I mentioned before, is regulation. Another is to start threatening lawsuits against these corporations. There are, of course, other approaches, but I'm kind of curious your thoughts on the lawsuit component.
Just quick. I mean, you got to realize that these are some of the deepest pockets ever in the history of the world, right? And I mean, the thing that showed up where the who was it? Facebook was just assessed a $5 billion fine, right? And their stock shot up. Everybody thought it was great news because it was only $5 billion. Wow, that's a different world. I don't know if your corner lawyer is going to be able to take that on.
Anybody else? Yeah.
Kind of a follow-up question. Here you go. So I'm going to preface this with I'm not entirely convinced of this point myself, but a lot of people have mentioned this to me. Do you think that education on privacy concerns and what these companies, the sort of data that these companies have about us, should be paired with education on like a financial value of what benefit we're receiving? I think if you showed people how much money they're saving per month by having free email, good search, Facebook, all that, honestly, I don't think many people would choose to cut off those services, even if they were fully informed. I would, but...
My answer to that would be, but at least if they're fully informed, is a decision that they can make, and then they can choose that that's worth it to them. But right now, they might not know, like, what they're paying for it.
So what you said, I'm actually one of those people who didn't really care about their privacy, because when I grew up, like this Google was this huge big thing for me, and as a kid, I grew up with this thing. Like it's been there my entire life, and I feel like it's like someone very close to me. I trust it, so I grew up with it. So for me, my default mode is
This is bias.
yeah. And the thing, this is fascinating, right? Because kids nowadays are growing up with this cell phones and technology, and for them, the technology is much closer than their parents. They're way more engaged with their social networks and the applications than their parents. And for me, that's the case for me. And yeah, so I think that making people aware is important. And again, evaluating the risks and telling why giving actual facts, why would it be dangerous to give away your data versus the benefits you're getting.
One kind of thing is like the auxiliary uses of data. Like for example, I was just became aware of the fact that virtually all of the weather apps sell location data. They need your location data in order to predict weather where you're at. And there's a whole marketplace of these data brokers out there who get this whole, and that kind of information, in terms of understanding that it isn't localized to that company that you've given permission to, right? But that it migrates and it gets pooled and all kinds of things happen with it, would be good.
So let's move away from Facebook data. That's in vogue. Let's talk about a little bit more sci-fi. Computer vision. So a video camera, which we're all on right now, and this is being put on YouTube Live, right? I have robbed you of your privacy. But let's say I didn't tell you. Right? So clearly there's an invasion of privacy potentially, depending on your view. So let's move away from Facebook and let's start talking about Amazon with Alexa, with the video, I forget what that's called. The Echo something, I don't know. In addition, police officers with cameras, right? There's several examples nowadays where video cameras could potentially record you. Now, this isn't privacy of your data. This is privacy of your face, of your body, yourself. Would you change your answers to some of the questions I've asked you before? In other words, how are you going to protect your privacy in this world where we have machines that are going to analyze you in every possible way?
I don't know. It frustrates the crap out of me. And despite the fact that I've spent my life in speech recognition, I think anybody who puts an Alexa in their home is just an idiot. Sorry, sorry for offending most of you, but I mean anybody who wants to set a live open speaker to Amazon or Google beside their bed stand and in their kitchen is, you've asked for it.
This is why I asked Jim to be on this panel.
I love my Google Home. Yeah, but I agree with you too. But it's just too convenient, at least for me. So I'm selling my soul to the devil.
How do you hold, like, so Abai, you said you like your Google Home. Yeah. I like my Echo. I'm an idiot. Sounds
Sorry
like
for the
AA.
term.
Hi everyone, I'm an idiot. Hi John. Anyway, Abai, so how would you propose we hold Google, and in my case Amazon, accountable, right? They're recording, so the potential. I read a thing, only read the headline, so I don't know the details. Alexa recorded everything, of course, that was in my household, and it was made available to some developers because there was some, quote, bug in the software. I don't know the details beyond that, but let's just go with that. How would I hold Amazon accountable? They heard some conversation that I had with my wife or with my son or whatever I was watching on TV, whatever. They heard it. How do I hold them accountable?
Accountable for what? You agreed to it. Yeah. You're fine. You read the fine print, which you probably didn't read, but you're perfectly fine with them doing that, and they can do whatever they want to with it.
This is gonna sound like really messed up, but I think like we're the first generation. We're sacrificing our privacy like for future models, and so I kind of think I think that's what we're doing. We're kind of committing mass privacy suicide for the future.
I don't know if I can follow that up, but an interesting idea that I have read about. Maybe some of you have heard of federated learning, but it's the idea that like if you're using like data from speech recognition, data from individual consumers is maybe as updates to some big overall speech recognition model, and you're pulling the data collected from 100 devices on the edge to update this model back in your home server. And so one idea has been basically that on those devices on the edge, so the individual components, maybe they retrain their model a little bit, and then they just send the updated weights back to like the master model in the server, and then that master model only updates after it's seen like 100 or 1,000 communications from individual devices. So therefore, you can't really, it's an enforcement, like any update overall is an average over n, individual devices, and at least abstracts a little bit more. We're not learning specifically from John's speech.
My concern there is interpretability, back to our original conversation.
Yeah, how do you know what they're doing with the data, right?
Yeah.
So I would ask, with relation to specifically to that and going to security and privacy, is the fact that beyond just facial recognition or ethical biases, is the fact that we're living in a world where we carry around something that's passing our health data. Now, of course, there's huge implications that are wonderful about collecting tons and tons of health data that is going to improve healthcare for future generations, going back to what you had stated just a moment ago. But also from the concept of continuously updating models. I'd be curious to see what the panel has to say about that.
Yeah, again, so the reason we know what vegetables we can eat and the reason we know what kind of food, like leaves and stuff, is because someone had to eat everything and die. So the people who didn't die got to eat. So I guess it's kind of like that. So you cannot get things for free. So we're sacrificing our like midget porn history for for the future models.
I got dark really fast. Anybody else?
Yeah, I was gonna say, I think that there are models that are different that can be done, and I will say that despite my rant about privacy, I'm wearing a Fitbit, and it's like it's the one place where I've
So
kinda
you're an
given-
idiot.
Yeah, I'm an idiot. I am. I'm part of that crowd. I'm not, I wasn't saying you idiots. That was me. Anyway, I have an idea about a company, like an idea that I think is a great idea to build out. I don't have the bandwidth to do it, but enforcing privacy and basically it's a mechanism by which you can do protected data inside, encapsulated protected data, and have a means by which we get the societal benefits of accessing that, and the owner of that data monetizes the data themselves via this. And if anybody wants a great idea to start a company, I'll be happy to share it because I don't have time.
Okay, let's move to final question. I've let you guys talk the majority of the time. I'm going to chime in on this one a little bit. My biggest fear as a kid was to be wrongfully accused of a crime. The more I read hard sci-fi, the more I became scared of it. To be like a future aware, and this is actually in Minority Report, the movie, in the Philip K. Dick
Could I
book.
interrupt you for just a second?
Yeah.
I just remembered the one big thing right now is the Andrew Yang was his universal basic income. So I think what we could do, we could turn this like we're giving our data to these large companies, right? But what we could say is you have to provide increase our baseline of society, like giving us like paying taxes
You
for
just
every
opened up a
transaction.
whole can of
Yeah.
worms. So let's keep going with it.
Yeah, but that's I guess one suggestion I forgot.
That's
I've
not
been-
something you can just throw into the
I've been
conversation.
holding it. I've been holding it in.
Not an interruption.
I saw 5 hands shoot up as soon as you said UBI. So go ahead. Well, I'll come
something
back
like
to my
that.
spiel. Okay. All right. We're going to move on from UBI because that's going to open up a lot of conversation. So before I say this, we're going to go to CU29 across the street right after this. So it's a cocktail bar if you haven't been there. We'll continue these conversations. We would love for you to come there. We usually have 10 to 20 people join, and this conversation will keep going, especially if Abai and Jim keep talking. All right, so previously I was talking about my childhood fear was being wrongfully accused of a crime. And the more hard sci-fi you read, the more you realize that we are converging on a world where that's true. Neil Stephenson, one of my favorite authors, he was in town a couple months ago. He actually talked about this very thing. Somebody asked him what are his 2 biggest fears, and he said 1, climate change. 2, his biggest fear is actually that we cannot as a society agree on what is truth. Most recently in the form of fake news. But his concern is not just so-called fake news, is we've gotten to a point where we can't even agree on a fact. This is a new phenomenon in the history of the human civilization. At least I'm thinking that's true. So that whole preamble. For the panel, there's this concept of deep fakes. I'll quickly define it. I'll refer you to Google or some other place where you're going to record your private information. So deep fakes, that was a joke, by the way. So a deep fake, to keep it very simple, is there are a variety of algorithms right now that can, how would you define a deep fake? To basically, I could take Jeffrey's face right now and put it on my face, and no, let's say it the other way. I'm talking, and I can make Jeffrey talk. He'll be like a human puppet, right? As I'm talking, I can make Jeffrey say whatever I want him to say in a video. There is even a whole Reddit, and it's a subreddit on this. People in that subreddit have gotten pretty crazy with this idea. If you're not familiar with what I'm talking about, you're in for a world of a whole night of very interesting videos. I'll just say it that way. So, I'm going to combine those 2 things I've just talked about. Fake news, deep fakes. Fake news was a big issue in the most recent presidential election. Fake news, I don't even think begins to touch what we're about to see in the next election cycle, but it's not limited to elections. Business, Jim posted in Slack an article where this is going to heavily affect business. I mentioned my childhood fear of being wrongfully accused of a crime. So there's 3 different scenarios. Limitless more. So the question, given that we know all of this crazy stuff that is likely going to happen, should researchers and practitioners cease implementing improvements to face and voice generation, knowing that these methods could be abused?
I think it's going to happen anyway, right? So that kind of is assuming that all of the like smart people are good people who are also working at Facebook and Google and are not into organized crime. And I don't think we can kind of rely on that assumption. So I think it's whether it's like a researcher creates it and makes it open source and it gets into the wrong hands, or it just gets created in quote unquote the wrong hands. I think it's kind of our future either way.
It's a dark future. Go ahead, Jim.
No, I agreed. I mean, it's you know, the genie's out of the bottle, Pandora's box is open, whatever you want to say, and you're not putting it back. And if even if you legislate against it in one place, you know, there are hundreds of countries in the world where your legislation doesn't apply. It's part of our future, and it's going to be kind of ugly, frankly. I think the biggest thing is that it's going to eventually erode believability of anything. Right, so so you could, a politician could be accused of something and plausibly say, no, I didn't say that. Even though they got video of me saying that, I didn't say it. It's a deep fake, right? Solution, I don't have one.
Yeah, and there are technological solutions, right? There is a whole field called adversarial learning, but the saddest thing is the more you push back, the stronger the problem becomes. So if you introduce this competition, it becomes like this arms race. So if you actually don't do anything, the problem will be like much more mitigatable. Like if you start fighting it with machine learning, it creates this arms race that no one is going to win.
Yeah, I was going to echo just that. I think the adversarial paradigm is one of the big features where it's constantly a cat and mouse game. There's basically, especially if things are publicly funded or you're open sourcing solutions, that pretty quickly is going to it's easier kind of for the adversary to find like one counterexample or one turn of a knob that breaks your system than that you can protect against everything. And that's always been the paradigm in security. It's challenging.
So I'm not satisfied with these answers whatsoever, and I hope the audience is not as well. So we've provided technological solutions so far. And I mentioned previously the next presidential cycle. How do you educate the public? Let's start with a simple question. Do you educate them now? If you do, how do you educate them now? Or do we wait for Pandora's box to truly open, where the entire public knows about this, and you have mass chaos?
Well, so the article that John referred to that I sent around was actually how some people had developed fake audio for, and some of you may have seen this, fake audio for CEOs. They take their like presentations, year-end presentations, they collect all this, and made the CEO call like the CFO and go like, I need money transferred immediately now doing this. And there's several companies have been hit to the tunes of millions of dollars. And with no foreseeable solution, like Symantec is claiming they're going to provide detection, but yeah, no, I mean, not realistic.
Yeah, Max.
Test. I just wanted to make one comment that we're talking about deepfakes a lot on a political scale, but it's a very personal scale as well. Almost all of the deepfake controversy I've heard of is basically like threatening to make fake pornography out of women to coerce them to usually give you like all of their like social security information and stuff like that. And so I'm much more concerned with these sort of personal deepfake problems. I think that like political, electoral things, I think it's gonna be hard to like make one fake video of Donald Trump and everyone's gonna be latch onto it. I think it could get sort of like verified by separate news outlets and stuff like that. maybe there'll be problems there. But I think that, again, this personal level is a much more threatening and sort of like life-threatening, like, oh, my life will be destroyed by these things. And I would maybe want to hear a little bit more about what the panel thought about those.
Like, I think regarding specifically the porn, right? We already have laws in intellectual property, so I think we should treat it as intellectual property. So, like, if you put a deep fake on YouTube, then you should pay the person who owns the face, basically. So, or like if there's a porn, like even if you have porn on a website, there are intellectual property laws that actually find the porn, and the website will be fined, or anything that traffics the pornography will be fined. So I think, yeah, when it comes to that type of media, like intellectual property laws would do at least some help.
First of all, enforceability, I think, is very, very hard in that situation to begin with. And then I also just really quickly wanted to touch on John's point about how do we inform the public, do we do this? I don't think we're going to need to. I think it's going to hit like a firestorm really soon. You know, again, as the quality goes up, the quality of audio, quality of video goes up, yeah, it's going to be very, very much in public consciousness.
So one of the scenarios I heard presented, call it a forecast if you'd like, is that right now, so rewind 20 years ago, news came from 3 or 4 outlets. Nowadays, news comes from thousands, if not more, outlets. It would be natural for, if you can't trust the thousands, you only trust a handful that are vetted, Fox News, or whatever, choose your 3 or 4, that it will basically, we will move back to a centralized news release. Kind of curious, do you agree with that? I'm not necessarily saying Fox News, but CNN, MSNBC, or do you see another alternative?
Yeah, the multiple sources of news and commentary and stuff are not going to go away, I don't think. I mean, I think that all of us do that to some degree, where we have ones that, like I'm reading through news and I flip through and I'm going like, and I'm like, wait a minute, who said this? You know, kind of thing. Like I'm reading the headline beforehand and then I look at it and go like, wait, you know. And so there are ones that you trust or distrust with a certain degree, but this is the same problem that would existed in the election. You have this polarization of news feeds that, you know, where, yeah, I mean, like one example that came up, so the congressman, the Republican congressman who came out when the Mueller report came out, denounced in a series of tweets, like he was from Michigan or somewhere, right? And got a lot of flack, went to his home state, did a town hall. A lady who came out to the town hall, so somebody who was involved enough, who supported him, came out to the town hall, listened to his talk, and was interviewed afterwards. And her response was, you know, so like, I had no idea that there was anything negative in the Mueller report about Donald Trump. And they asked her, what's her source of evidence? She said, she's basically let Fox News listen. And so despite everything that had been said, she had no clue, right? And it just shows you, and I think it's going to be an exacerbating problem, not one that's getting better.
I think just one thing to add about, I think, like the ecosystem around the media and information is that people are, you know, taking in smaller pieces of media, like bite-sized content, which are more amenable to kind of these deep fake productions, both in terms of video and audio. It's a lot harder to produce something, a 90-minute video that is faked, or a 500-word article. But if we're reading 180-word tweets and watching 5-second, you know, looped videos, that's more susceptible to these kind of productions.
Just kind of hitting on one more time with, you know, the fact that all this has been based off the idea that, you know, we've got machine learning algorithms that are paying attention to news sources, things like that, creating positive feedback loops. In these types of, in today's society, it sounds like we could almost claim it as like a denial of truth attack. Like you could actually have enough news sources come out with fake news to actually influence algorithms to further bias them in the way that you want. What do you think of that?
Is that copyrighted? Denial of truth attack? No, I like it.
So just in case anybody did not hear, the gentleman in the front said news agencies have been doing this for a long, long time. Anyone else want to chime in? We just got a couple more minutes and we need to wrap up.
We have more data points about this problem. Let's say this problem's been around for a long time. So is it just a question of that we're looking at the data now, whereas we just didn't think about the data as much before because they didn't really teach literacy and how you determine what news sources are good in school. I don't know. That wasn't a big topic. So now we just have more data on it.
One is the cycle speed has greatly increased. The volume, the rapidity with which things can be run through. But I think your point about what gets taught in school is actually quite interesting. I think that critical thinking skills as something to be taught in school is absolutely essential, because you have to be able to discriminate among the sources and understand what's worth paying attention to, what isn't, and understand biases. And my sense, at least historically, schools have failed to focus on that kind of thing, and that should change.
Yeah, let's close with this. I just want to add one thing. This is not unique to modern day. Medicine has been dealing with this for a long time. So you have a variety of studies that are out there, and you have to make a decision about somebody's life. What do you do? If you're a doctor, right, you have to consult a variety of different forms. Those studies may be flawed. The data sets in those studies might be flawed, and doctors have been doing this for a long time. They haven't gotten it perfect. And if there's anything to learn from that, is that we're not going to get this right for a while. Because in some of the simpler medical cases, these are textbook probability solutions. And even then, doctors still get it wrong in the most simple cases. How much more complicated does it become when you start adding more complicated other kind of data? So I think the biggest concern for me is that it's going to take a while to get this right. And that's very scary as when a fire hose opens up, as Jim said. Let's close there. Thank you so much to the panel.